Assalamualaikum everyone. Welcome back to my video tutorial in high school chemistry. Today's episode is a sequel to the previous upload titled The Limiting Reagent in a Chemical Reaction. This time we focus on the theoretical yields of a given chemical reaction. So just stick around, watch and learn. The question is, if 1.0 mole of CH sub 4 or methane and 2.0 moles of Cl2 or chlorine gas are used in the reaction, 1 mole of methane plus 4 moles of chlorine gas yield 1 mole of carbon tetrachloride plus 4 moles of hydrochloric acid, then which statement is true? Letter A, the theoretical yield of carbon tetrachloride is 1.0 mole. Letter B, some chlorine gas will be left over. Letter C, the theoretical yield of hydrochloric acid is 2.0 moles. And letter D, all of the methane gas will be used up. The given chemical equation is 1 mole of methane gas reacts with 4 moles of chlorine gas, forming 1 mole of carbon tetrachloride and 4 moles of hydrochloric acid. Notice that this equation is already written in its balanced form. We emphasize that based on the balanced equation, 1 mole of methane requires 4 moles of chlorine or chlorine gas for the reaction to completely proceed. The given problem specifies that only 2 moles of chlorine gas are used, so we ask how many moles of methane is needed. Or, translating this relationship into a ratio and proportion, we have 1 mole of methane divided by X mole of methane equals 4 moles of chlorine gas divided by 2 moles of chlorine gas, where in this ratio and proportion equation, all right, the variable X is the required number of moles of methane to react completely with 2 moles of chlorine gas. So solving for X, we get X equals 1 mole of methane divided by 2. And we will get the value of X equals 0.5 moles of methane. So this 0.5 moles of methane is the actual number of moles of methane that is used up out of the given 1.0 moles of CH4 or methane. Similarly, we also find the theoretical yield of the product HCl or hydrochloric acid So based on the balance equation, 4 moles of chlorine gas reacting with 1 mole of methane will yield 4 moles of hydrochloric acid. Since only 2 moles of chlorine gas is used as given in the problem, okay, we will find the number of mole X of HCl, right? And translating it into a ratio and proportion equation, we have 4 moles of chlorine gas divided by 2 moles of chlorine gas equals 4 moles of hydrochloric acid divided by X mole of HCl or hydrochloric acid, where our task is to find X or the number of moles of HCl or the so-called theoretical yield of the product HCl. And so solving for X, we have X equals 4 moles of hydrochloric acid or HCl divided by 2. And we will get the value of X equal to 2 moles of hydrochloric acid. So 2 moles is what we call the theoretical yield of hydrochloric acid or HCl. What is the theoretical yield of carbon tetrachloride? To answer this, we take note that based on the balance equation, 4 moles of chlorine gas reacting with 1 mole of methane yields 1 mole of carbon tetrachloride. And since only 2 moles of chlorine gas is used, all right, we find X or the number of moles of carbon tetrachloride that is produced. Again, translating the relationship into a ratio and proportion equation, we have 4 moles of chlorine gas divided by 2 moles of chlorine gas equals 1 mole of carbon tetrachloride divided by X mole of carbon tetrachloride. Right? So, solving for the variable X, we have X equals 1 mole of carbon tetrachloride divided by 2. And that means X equals 0.5 moles of carbon tetrachloride, which is the theoretical yield of carbon tetrachloride, okay, being one of the products in this reaction. We can evaluate our results, all right? So in the actual experiment, we see that 0.5 moles of methane, okay, was made to react with 2 moles of chlorine gas, and this reaction produces, all right, 0.5 moles of carbon tetrachloride and 2 moles of hydrochloric acid. So, adding the number of moles of the reactants as well as for the products, we get 2.5 moles of the reactants and also 2.5 moles for the products. And in terms of the mass equivalent in grams, all right, uh, zero point 0.5 moles of methane is actually 8 grams. This is determined by simply multiplying zero point 0.5 moles by the molar mass of methane. So that's how we got 8 grams. And in the case of chlorine gas, 2 moles of chlorine gas is also multiplied by the molar mass of chlorine gas, and we got 142 grams. And for the products, zero point 0.5 moles of carbon tetrachloride is multiplied by the molar mass of carbon tetrachloride, and we got 77 grams. And lastly, for hydrochloric acid, 2 moles of HCl is multiplied by the molar mass of HCl, and we got 73 grams. So adding the mass in grams of the reactants as well as the products, we get 150 grams as the total mass of the reactants and 150 grams as the total mass of the products. So you see, all right, comparing the number of moles of the reactants and the products, we say that they are the same. And in terms of the mass equivalent in grams, the mass of the reactants is also equal to the mass of the products. So these two results, all right, obey or agrees with the law of conservation of mass. So going back to the question, which of the statements is true, right? So statement A says that the theoretical yield of carbon tetrachloride is 1.0 mole, right? So based on our earlier calculation, this statement is incorrect because the theoretical yield of carbon tetrachloride is in fact equal to 0.5 moles. Statement letter B, some chlorine gas will be left over. This statement is also incorrect. All right? All the 2 moles of chlorine gas is used in the reaction. All right? So, that's also incorrect. Now, let's go first to letter D. All of the carbon or methane will be used up. Okay? So, this statement is also incorrect because as earlier calculated, only 0.5 moles of methane or CH sub 4 is used up, all right, out of the 1 mole of carbon or CH4, also known as methane, all right. So out of the 1.0 mole of this compound, only 0.5, okay, is actually used up, and therefore there is an excess of 0.5 that is left over. That means statement letter D is also incorrect. And statement letter C, the theoretical yield of hydrochloric acid or HCl is 2.0 moles. All right, and this was shown earlier to be the theoretical yield of the product HCl. So this statement, therefore, is the correct statement. And so that concludes our tutorial for this topic. Till the next episode, mabuhay, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.